Hi folks, welcome to the 7.7 videos. We're going to be talking about double integrals over more general regions. Now for this lesson, we're going to split it up into three separate videos. And so in the first video, we're just going to talk about regular regions and like what a regular region is. And in the second video, we'll actually tie that together with the double integrals that we learned from the last lesson. And in the third video, we'll take a look at some more applications of how we might use that. Okay, so let's get started with this video. All right, so a few skills we want to master here. Recognize when a function of two variables is integrable over a general region. That's really what we're going to focus on in this first video, okay? In the second one, we're going to be actually evaluating the double integrals by computing an iterated integral like we talked about last time. And in the last video, we will talk about changing the order of integration and using double integrals to find volume of a region between two surfaces. All right, so let's get started with our regular regions over here. Last time we met, we talked a lot about something called rectangular regions. And when we said rectangular regions, we meant that like we had sort of like two x values, two y values, and then in the inside of those x and y values was a rectangle, okay? But you'll notice that these four shapes that we see here, we sort of see like non-rectangular shapes, okay? And so when we say regular regions, what we mean is non-rectangular shapes, okay? And so it's going to give us a lot more freedom to do more complicated things, but I know that can also feel a little intimidating. So one of the things that we're going to focus on in this first video is really looking at the difference between the two kinds of regular region, okay? So let's take a look at this diagram over here. This one is considered a regular X region. And the clue that we have, what we call a regular X region, is that there's going to be a clear top function. In this case, it's our y equals f of x, okay? And we're going to have a very clear bottom function, which in this case is our g of x. And those are going to be functions. They're not going to be just a number, okay? Then the other clue is we will have a number for x and a number for the other x to kind of slice off that region, okay? So when we say a regular x region, we mean the y's are equations and the x's are still numbers, okay? So let's write that down. That we have, where should we put it? I'll squeeze it in here. Regular region has y's as equations, and it has x's as numbers. Okay, so y's as equation and x's as numbers. All right, now if we kind of move our eyeballs over to the right, we see we have a regular y region, okay? And this one is going to be almost like a rotation of what we had with the regular x region, okay? So instead of having a clear top and bottom function, we have a clear right function, and we have a clear left function, okay? So instead of having a top and a bottom, we have a right and a left. And instead of the x's being numbers, the y's are going to have numbers, okay? So let's take a moment to write that out. We've got our x's as equations and our y's as numbers. All right. And if you forget as we're going through the lesson, you can always come back and look at this picture. I think it's a really good one to see like sort of a top bottom or a right left. Okay. Now, there are some that can be both. Like this picture right here, we could see it as like the blue curve is on top and the red curve is on the bottom. Or we could see it as the red curve is on the right and the blue curve is on the left. Okay, so some regions can be both, and that's going to be something where we practice writing it in two different ways. Because sometimes one of those ways is going to be a lot easier to integrate than the other. And so even though it might be more work in the beginning to set up like two different integrals, at least we can then choose maybe one that looks a little bit smoother than the other. Okay. And then we're not going to worry too much about the ones that are neither an X or a Y region, but they do exist. And I wanted to show us a picture of it that it could look like this, where there's no clear top or bottom, because like this top and bottom is different from this top and bottom. Okay. And then like this left and right is different from this left and right. Okay. So we're not really going to worry about those, but just know that they exist. Our focus is going to be on regular X regions, regular Y regions, and then thinking about those cases where they might be both. Okay, so let's get started. All right, definition time. Definition of a regular region. A region R in the plane XY is a regular X region. All right, so this is a regular X region. If there exists a function f of x and g of x and the numbers a and b such that, check this out, we have a top function and we have a bottom function for y, okay? And then our x's are bounded by numbers, just like when we did the rectangular one, okay? Now, similarly, a region R in the xy plane is a regular y region if there exists two functions, h of y and k of y, such that we have a left function and a right function, and our y's are bounded by numbers. Okay? So we're going to look at a lot of pictures and see if we can't use those to help us figure out like what we mean by top and bottom and what we mean by left and right. And honestly, this section is a lot about the algebra setup of things, because in the next video, we're going to need that algebra to go ahead and set up the actual iterated integral. All right, so we've got these two pictures right here, right? Describe each region as a regular X region or a regular Y region, okay? So let's actually start with diagram A over here, right? Now it's a really tall one, right? When I screenshot it, it's like giving a lot of height in the actual text box over here. But if I look at this region, I notice that like the region is sort of this like tan colored area over here, all right? And everywhere inside of this tan colored region, we have this y equals 4 minus x squared that is on the top. And then on the bottom, we have our y equals x minus 2, okay? So let me see if I can make that just a little bit more clear, but we have a top function over here given by this, and then we have a bottom function down here given by this, okay? And so again, when we say top bottom, we mean like if we drew a line, a vertical line anywhere in here, the blue curve would always be on the top and the red curve would always be on the bottom, okay? Because we see a very clear top and bottom, okay? And I don't know why I didn't write that, but this is our bottom curve. And this is our top curve. That means that we have a general X region. Okay, that's what it looks like, a general X region. It's sort of a weird shape. It's not a rectangle, but we can see a very clear top function and a very clear bottom function. Okay, now how are we going to write it like this? That's what I want us to practice now. Okay, there's a lot of sort of notation happening here, but we're going to start with R equals, that means our region equals, and then we're going to open a squiggly bracket. Okay, inside that squiggly bracket, we're going to write parentheses x comma y, because we want to choose points x and y from inside this space. And then we're going to draw this line, which is a really fancy way of saying such that. Okay. And then we're going to put in our top and bottom functions sandwiching our y, and then we're going to have a comma, and then we're going to write our a and b numbers that sandwich our b. Okay, so it's a lot, but let's walk through one. Okay, so general X region. This region we can define as open up that squiggly bracket, parentheses x comma y, close it, such that. Okay, that's what that line means, such that. Now I need to write the bottom function and then less than or equal to y, less than or equal the top function. Okay, so the bottom function is x minus 2 is less than or equal to y is less than or equal to the top function, which is 4 minus x squared. Okay. This is our top. This is our bottom. Okay. So we've got our top minus bottom sandwiching the y. And then let's see where the x values start. Looks like the x values start here at x equals 0, and we go all the way over to x equals 2. Okay, so to finish off our notation, we're going to go from 0 to x to 2. And that's our a and b for x. We're done. Now we close our squiggly bracket. Okay. And look at that. You've now just written your first description of a general region, a general X region from our diagram. Okay, so good job, you. We're going to try it again with example B and see what kind of region we have and then practice writing that notation again. Okay. All right, so here is our second diagram. And I think immediately we might see this is a little bit different, right? This picture is a little bit wider when I cut it out. That's not always the indicator, but look at this. We have this line that we're drawing horizontally. And on this line, I can see a very clear right function and a very clear left function, okay? This is our indicator that we have a general Y region and not a general X region. Okay, so right and left. And this left is this piece right here. And our right is this piece right here. And any horizontal line that goes between them will always have the same function on the right and the same function on the left. Okay. All right. This is our indicator, as we said, that we've got a general Y region. And so before we write our notation, let's go back up and look at our definition. Okay, so it's a regular Y region, then we write R equals, just like we did before, open a squiggly bracket, parentheses, x comma y. But here's where it's different. We have the left x and then the right, and then we have C, Y, and then D. Okay, so the numbers are going to be along the y-axis, and our functions are going to have y's in them. All right, so let's try writing it. R equals squiggly, parentheses, xy, close it, such that. Okay, now we need the left function first. So our left function is the y squared. Then I'm going to sandwich that on the other end with 6 minus y. Okay, so y squared and x and 6 minus y. All right, and this is our right function, and this is our left function. And then we have to talk about the numbers for y. So it looks like this tan area starts at y equals 0, and it goes up to y equals 2, okay? So that means that we're going to have 0 less than or equal to y, less than or equal to 2, and we close our squiggly, okay? So that is our setup if we're finding a general y region, right minus left. And then if we go back to the other screen, top minus bottom means we have a general x region, okay? All right, let's practice this one more time, and then we'll move on to our second video where we actually practice our calculus. Okay, so example number 2, describe the region R as a regular X region and a regular Y region. Ah, man, what a good test question, right? Being able to do things in multiple different ways is a really great way for you to demonstrate that understanding. So I've got this region here. Let's do the regular X region first, and then we'll do the regular Y region, okay? So I'm gonna set up here for my general X region. All right, and I'm just gonna write out the general form here since the other one is on the other page. R equals squiggly, parentheses, x comma y, such that we need a bottom function, y, and then a top, and then we need an a is less than x is less than or equal to b. Okay, so those are the pieces of information we need to fill out. Okay, so let's start with the top and the bottom function. In our picture, I think we can really clearly see that this blue function is the top function and that our red function is our bottom function, okay? Now, I can't just put x plus y squared equals 9 in for the top. And I can't just put x plus 3y equals 9 in for the bottom. I have to use some algebra to rearrange what I'm writing, okay? So you notice that there's a y in between here. This actually tells you what you need to do to your equations, okay? Since I have a y here, what that means is I want to take this equation and I want to get y all by itself. And I want to take the blue equation and I want to get y all by itself, okay? So let's do that algebra, okay? So up here with the blue function, all right, so x plus y squared equals 9. If I want to get y by itself, I'm going to subtract x over, so y squared equals 9 minus x. And then to get the y all by itself, I need to square root both sides. So I get y equals the square root of 9 minus x, okay? Now, technically, there's a plus and minus, but because we only have the top part, it's just the plus, okay? So now that I have y equals the root of 9 minus x, that's what's going to go in for my top function over here. All right, well, let's do the same thing with the red function. we've got x plus 3y equals 9. I want to get y by itself, so I'm going to subtract x. So 3y equals 9 minus x. And then I'm going to divide everything by 3. So I get y equals 9 over 3 minus x over 3, which is the same thing as saying 3 minus 1/3 x. Okay? And that is what I'm going to put in for the bottom function. All right, before we go writing our full region, let's figure out what the x and y or x values are that sort of slice our graph. And it looks like our picture starts at x equals 0 and goes all the way to x equals 9. So that means A is going to be 0 and B is going to be 9. All right, let's put that all in here. So we've got r equals squiggly parentheses x comma y such that the 3 minus 1/3 x is less than or equal to y is less than or equal to the square root of 9 minus x. And we're going from 0 all the way to 9 for the x value. Okay? So that's how we would write a general x region. Now let's go ahead and redo all this, but with a general y region. Okay? So I'm going to go ahead and shrink this a little bit. Okay. And just like I did for the x, I'm going to rewrite the equation for the general y region. Right? And so my r is going to equal some point xy such that I have the left, which is less than or equal to x, which is less than or equal to the right, and y is sandwiched between some numbers c and d. Okay? All right. So let's go back to our picture for a moment, okay? Last time, I said we're going to take these equations that were given and we're going to go ahead and get y by itself because we had a y inside the top and the bottom, okay? Now, if we use that same reasoning, I've got an x between the left and the right. So what that means is I need to go back to my equations and get x all by itself, all right? So let's do the one in the blue first. And if I'm considering this one my right function, I want to solve for x. So x plus y squared equals 9. Wow, the only thing I need to do to solve for x is subtract that y squared. So I get x equals 9 minus y squared, and that is going to be what I plug in for the right function down here, okay? Now let's go back to this red function. This bottom goes with this part. And if I want to show that this is a left, I'm going to solve for x. All right, x plus 3y equals 9. The only thing I need to do to get x by itself is subtract that 3y. All right, not too bad. Now, just like before, we're going to plug in all the things. So our 9 minus 3y goes in for the left. Our 9 minus y squared, that goes in for the right. The last thing we should do before we scroll off the screen with the diagram is figure out the values that bound our y. Now I see that the bottom of this region starts at y equals 0, and the top of this region ends at 3. That means my C is 0 and my D is 3. Okay, so let's go ahead and write that all in. R equals squiggly parentheses x comma y such that 9 minus 3y is less than or equal to x, is less than or equal to 9 minus y squared. And we said that our y values are bounded between 0 and 3. Okay. All right. So here we have it. We're at the end of our first video. If you feel a little confused by this, maybe try some of the homework questions, maybe watch this part again because these skills are going to be important in video number 2, where we take a look at actually using the calculus from this setup. Okay, so I'll see you in the next video.